like 0.0.
Oh, sorry.
No worries. Carbon dioxide comprises about 0.041%, right? So a tiny fraction of the atmospheric gases. Carbon dioxide is one of those very thin or low concentration gases. Water vapor is another one, right? Methane is another one. There's a collection of these gases that in very low concentrations play such a disproportionate role in our climate and in moderating our temperatures, and of course allowing life to be here on planet Earth. So from an atmospheric perspective, or at least from a climate change perspective, nitrogen and oxygen are dull. It's the other things that are really quite exciting. Frank, why don't you just touch the screen there, because yeah, I just, with the mouse, just, there we go. It does that. All right. So that's the first point. The second point is, when we look at our planet out in space, like all the other objects, the other planets in our solar system, our Earth interacts with the radiation that we get from the sun. So we get this vast sort of nuclear explosion, if you like, from the sun, and it sends out radiation in the energy in the form of radiation. So this is high intensity shortwave incoming radiation from the sun, and our planet absorbs just a tiny little fraction of that. And that energy, of course, heats up planet Earth, and we become an emitter of radiation, right? Now, we emit radiation in very different wavelengths. So we are emitting long waves, infrared radiation. And the remarkable thing, I think, is that if we didn't have an atmosphere, so if we took all of those gases away from that first slide, if we took the oxygen, nitrogen, and carbon dioxide, all of it away, and we just let our planet equilibrate out in space, in other words, how much radiation we get and how much radiation we give off, then our planetary temperatures would be something like -18 degrees Celsius. So the Earth would be a frozen ball, right, if we didn't have this atmosphere. I'm sorry, I'm a Celsius guy. I know you are Fahrenheit yards and fathoms people, but so you can just multiply by 1.8 and add 32. So, so our planetary temperatures would be -18 degrees Celsius. And then, of course, what we do is we wrap around this envelope of gas, and those gases like carbon dioxide, methane, water vapor, the so-called greenhouse gases, what they do is they short circuit this emission of radiation from the Earth back to space, right? So these long blue arrows, those gases will selectively absorb that. And I've decided to leave out all the electromagnetic spectrum stuff and all of that. That's probably overkill on a Monday evening. But this is just my attempt to summarize what goes on in terms of how energy is processed from the sun. So on the left-hand side, we've got these dark orange, the dark sort of very ugly longhorn orangey colors coming in. And if we just look at it as percentages, we've got 100% incoming solar radiation. About 30% of all the energy from the sun plays no role in heating our Earth atmosphere system. That's what we call the albedo, that's reflection. So about 25% is reflected off clouds and about 5% is reflected off the surface of the Earth on average. So that 30% plays no role in this kind of thermodynamic heating of our Earth atmosphere system. 19% gets absorbed by the atmosphere, so stratospheric ozone plays a big role there. So the bottom line is about half of all the energy we get from the sun actually makes it to the surface of the Earth and heats up either the terrestrial surface or the oceanic surface. So the Earth then becomes an emitter of radiation, and it emits all this long wave radiation, which is the big orange arrow going out. But it is these gases, right? These carbon dioxide, methane, water vapor, and other so-called greenhouse gases that absorb that energy being given off by the Earth. And then that in turn re-emits that energy back towards the surface. I know a lot of people sort of think of it as a blanket, think of it as trapping energy. That's not how it works at all. It doesn't even remotely work how like a greenhouse works. So it's a bit of a shame that it's called the greenhouse effect, but nonetheless, that's what happens, right? So this little arrow down on the right here, the greenhouse effect, is fundamentally critical to our existence. And the only reason I really mention that is that I hear quite often people sort of conflate the greenhouse effect with global warming and human influence and climate change. The greenhouse effect, of course, is just a naturally occurring process and accounts for our planetary temperature not being -18 degrees Celsius, but a positive 15 degrees Celsius. So it's quite remarkable that there is about a 33 degrees Celsius swing in what our temperatures should be relative to what they are. And you can look at this, this will be the end of the greenhouse lecture, part of this, but if you I've just taken one example. So if you look at Venus on the right and the Earth, Venus on the left and Earth on the right. So Venus, of course, is much closer to the sun. The Earth is about 93 million miles away from the sun. And Venus, even though it's getting more incoming solar radiation, you can see about twice as much radiation hits the top of the Venusian atmosphere, right? 645 watts per square meter. If you're desperately nerdy and want to know what that is, that's what that number is. About half of that hits the top of the surface of our atmosphere here. But of course, the Venusian atmosphere, one, is very, very dense, right? It's about 5 times as dense as Earth. But you can see just at the bottom here, the Venusian atmosphere is made up of about 96% carbon dioxide. That's a little different to our 0.04%, right? So the Venusian atmosphere has what we call a runaway greenhouse effect. Yes, it's a denser atmosphere, but it's almost completely packed with carbon dioxide. So the temperatures on the surface of Venus is a nice balmy 460 degrees Celsius, right? We happen to be about 15 degrees Celsius. So that's, I always look sort of like my students to appreciate that we really are this kind of Goldilocks situation here in terms of the composition of the atmosphere and the fact that our temperatures are livable. Does that make sense to everybody? This is probably old hat to everybody. Okay, so that's the greenhouse effect. We are underway. We're 11 minutes in and ahead of schedule. Okay. All right, let's talk then about climate change and global warming and get to the second part, which is something that really interests me, and that is how this is portrayed in the media and how we get to sort of interact with this topic. You know, if you do, and just incidentally, global warming and climate change, a lot of people use those interchangeably. In the scientific literature, there's something very distinctive about those two terms, right? Global warming refers specifically to the anthropogenic rise in global temperatures, right? Human-driven or acceleration of global temperatures. That's global warming. Climate change is a much broader term that encompasses changes in precipitation, changes in habitat, species diversity, and things like that. So they are related, but a little bit different. Anyway, if you do a Google search on global warming, I don't know if these are the first 3 images that come up, but you will see images like this, right? If you do a global warming climate change search. Undoubtedly, you'll see the poster child, the polar bear clinging to a melting ice cap, right? You're almost certainly going to see pollution spewing into the atmosphere. You'll see storm damage from hurricanes and so on, right? Very, very common images when we think about climate change and global warming. And I don't think there's any doubt that climate change is now increasingly portrayed in these sort of, I don't know if cataclysmic terms, that's perhaps too strong a word, but certainly there's this kind of doom and peril and, you know, imminent danger kind of wrapped around this term, climate change. I don't know whether that's a good thing or bad thing. It is what it is. I don't know. Environmental scientists perhaps really kind of often we're not heard, and so we perhaps overstate our case sometimes. But if we just look at where people get their information from, right? I know these are pretty dated covers now. These are about a decade old, but these are the first 2 covers of Vanity Fair's so-called green issue. And I use these in my classes to get my students just to think about the kind of phrasing that you see here, right? On the left there, so global warming is a threat greater than terrorism. You know, now that may be the case, right? But to many people, they stop and go, I don't know about that, right? Really? I mean, is global warming that big of a threat? And I'm not arguing that it is or isn't. I'm just throwing it out there, is that's the kind of, you know, that's the kind of descriptive language that we see when we think about global warming and climate change, right? We need a new American revolution. And so there are the climate, you know, the climate crusaders, Al Gore, George Clooney, RFK Jr., and, you know, Julia Roberts, all looking very eco-green in their outfits, right? And then on the right here, of course, is Leonardo DiCaprio, who's done some really wonderful work in terms of environmentalism. And, you know, I mean, now it's not just a polar bear, right? It's a baby polar bear that's looking up at Leo. You know, now that he's survived Titanic, he's got to save the world and you know, save the polar bears. Again, 2 dated covers here from Time magazine. I just want you to look at the phrasing, right? This is a global warming survival guide, and we don't just have to be worried. We need to be very worried. We hear things like tipping point, planetary boundaries, irreversible change, things like that, right? People are getting a lot of stuff thrown at them in this current environment, and I think people are beginning to go, you know, geez, man, how do I process all this? Who's right and who's wrong? Okay, so, you know, I'm often asked,
Maybe you can look forward.
Maybe I can what?
Well, I had it here a minute ago, but you could look forward
To,
rather than looking to the side.
oh, I see. Yeah, that'll work.
Try to
Okay.
make it easier.
No, no, good. Thanks. Boy, Frank is on this. We've got iPhones and anything. Okay, cool. Thanks. So I'm often asked, whether I believe in this global warming thing. I mean, very often that's how it's phrased to me. And at the end this evening, I'll just give you my kind of 30-second elevator pitch. It's amazing how often I sort of feel myself fumbling around that. I should have this kind of, quick answer down, but I don't, because very often people are, they ask that, and it's so tempting to say, well, of course I believe in this global warming thing. Who wouldn't? Well, it comes across as very self-righteous, and I think that some people may just genuinely not really know. But I do know that I tend to get put into one of two boxes very quickly. If I say, well, yeah, I think global warming is real and I think humans are driving it, then clearly this is my guy, right? I am in this box with Al Gore, who, of course, did An Inconvenient Truth and was a big proponent of policy to curb greenhouse gas emissions and so on. You all know who Al Gore is, right? But if I was to say, well, no, I don't think this is real. I think this is some Chinese hoax, or I think this is someone's made up this liberal conspiracy among the climate scientists, right? Then, maybe this is your guy, right? You get put into this pigeonhole, and you become, either a climate skeptic or a denier. And I know those are two different things, but nonetheless, you end up in these two boxes, right? And it's very difficult to get out of that. I think once you're in there, I think you get very defensive. I think that's what I found about trying to navigate global climate change. There is a bias, right? And this is, I think, some pretty interesting research. It's a couple of years old now. This was done by the Pew Research Institute. And I'm just going to take two little highlights from this report. It's well worth looking at, and the link is there at the bottom. And as I said to Mary Beth, none of the stuff on these slides is proprietary. You'll have access to this PowerPoint. You can use the slides, absolutely. But this is a really interesting report, and they looked at a broad set of environmental questions. But this one interested me in particular. This is the percent of US adults who think the federal government is doing too little to reduce the effects of climate change, right? So anything in blue, this 90% are those who identified themselves as Democrats or leaning Democrats. And then you can see how the others break out, right? Republican or leaning Republican, it was just under 40%. But it is not that all Republicans are climate deniers or skeptics, right? And I think often, I don't know about how you feel or interact, but I often get that impression, right? That those who support global warming or climate change are Democrats, and those who are anti it are Republicans. I don't think that's true. There is a bias. And what's quite interesting is when you look at the Pew data, as they started digging into not just those who identified themselves as Republican or leaning Republicans, but look down here, you can see those who identified themselves as moderate or rather liberal Republicans. You can see how dramatic that number increases. And I personally noticed that. In the last 10 to 15 years, I've been at TCU now 20 something years, and so there are some people in the audience who are old grizzled veterans, right? Who came to TCU. When were you there, Robert? I don't know.
Why do you look at me?
I don't know. 10, 15 years ago, something? 2006. So it's been 15 years, right? So I don't know what your perception is when you were a student at TCU, but I know 15 years down the line, I'm seeing quite a different attitude among the students, right? They seem to be much more aware of these environmental issues. They seem to be more engaged. Yeah, again, there's bias, but I'm noticing a change. And I think you see that in the age breakdown, the kind of boomers and the older generation, at least according to this research, is a little more swayed towards the one end of perhaps being more skeptical versus the millennials and youngers. And the other interesting question here that came up was the percentage of US adults who say that human activity contributes to global climate change. The blues are a great deal or some, right? So you can see that almost 80% of those surveyed in this really extensive survey in the US say that human activity contributes either some or a great deal to climate change, right? So when I travel overseas, I was just back in South Africa 2 days ago, I know there's this perception that the majority of Americans think that climate change is a hoax, or that's just not true. right? So this is one of the big challenges, is how we navigate this bias which exists, but is changing, and why it exists. I think part of the reason why it exists, and there's, well, suddenly this doesn't seem to want to click forward. It's stuck on the, there we go. Cool, thank you, Frank. I think there's some really interesting work that's being done out of Yale University, and I encourage you to go and look at that. It's by a guy called Dan Kahan, Kahan. He's done a lot of work around cognition and perception on climate and climate change. And, you know, this is probably not news to any of you, especially over the last, I don't know, 4 to 8 years, whatever the time frame is. We seem to have become so tribal, right? You're either in your tribe or you're not. And if suddenly someone says, well, you know, I think maybe there is something to this global warming and we better do something about it, then again, you go back and you're, you know, you must have voted for Hillary. What are you doing on our side of the table here, right? And so I think this notion that, at least I'm seeing this as well, we tend to see people endorsing whichever position reinforces their connection to others and those people that you actually have really important ties to, you know, family members. And I know that in my own family, my extended family on my wife's side, right? There are some that are, well, what are you doing? This is just one big hoax, okay? And there are others that are not, right? They're on a slightly different view. So that's one of the great challenges I think we currently face.
What advice do you give for that? I mean, being where, I mean, I have the same thing. I have
Yeah.
kids too, so we have a split family. And
Right.
you're looking at it, they're politicizing stuff that's science. It doesn't
Yeah.
need to be politicized. It's fact.
Yeah.
Fiction. I mean, this
Yeah.
is like what the data shows, and you don't want to argue with family members, you know, in front of your children and this and that, and say, you know, they're wrong, blah, blah, you know, throw name calling.
Right.
So what do you do when you explain it to people?
So I'll show you, I'll do that at the end. I'll show you my little 30-second thing. And so that works for me. And I experienced that exact same thing. I mean, I know I remember when my wife and I, when we were dating about, 11 years ago, something like that. And I think I was on the first edition of writing this textbook. And I was down at my wife's family out at the ranch and everything. And my soon-to-be brother-in-law, Lauren, my wife, said to him, you know, he asked, what are you doing? And I said, I'm just writing a book. And he said, what's it on? And I said, oh, it's called Contemporary Environmental Issues. And he said, so is that fiction or nonfiction? And I'm like, well, you know, and so, yeah, so I hear you. I think so I'll circle back at the end on what I do. But just to your point, again, it's very tempting to kind of, you know, to sort of do the, well, you know, I have a master's degree or I have a PhD and I've published some papers. And so, of course, I'm right? Of course, global. I mean, if you try and bamboozle people with science, you know, nowadays, everybody, they just 5 minutes and you're an expert on the internet. Okay. So the giveaway, before I do that, when I wrap this up, one of the giveaways is I always ask them, so that's really interesting. Why do you think that? You know, what makes you think? You know, because again, they may just be curious or they may not, they may be entrenched in their ways, right? I always try and find out what's important to them, right? Because I find, even though tonight's lecture is titled Carbon and Climate Change, I find in Texas, when you go in waving the carbon flag, most people sort of go, wait a minute, you know, I'm in the fossil fuel industry, or my father-in-law owns his own oil company. So that immediately alienates a large group, right? What I found is that most Texans actually really do appreciate clean air and clean water. They don't want mercury in their environment. They want, you know, good wildlife. So I just sort of rephrase the question, you know, and say, well, you know, if we're adding carbon dioxide to the atmosphere and that's turning up the global thermostat, if indeed that's happening, maybe we should, you know, navigate a different path. But I'll circle back at the end. It's not easy, right? It's especially when it comes to family. And yeah, politics and climate change and religion and sex at the Thanksgiving table. That'll get us going. And then the other thing that I think that's quite interesting, and I always like to just sort of emphasize this, is, you know, very often the environmentalists, the conservationists, the master naturalists, whatever group, you know, we have, will point at, you know, big oil or big energy, whether it's Shell, BP, Exxon, or whatever the case may be. Now, 20 years ago, maybe even more recently than that, you know, companies like Exxon were funding research that was specifically driven to try and poke holes in the climate science side of things. But, you know, Shell now, and certainly BP in the 1990s, were really starting to come around to the impact of fossil fuels and that we need to navigate a different path, right? So, you know, these CEOs are not saying that climate change is not happening and that humans have nothing to do with it. You know, that's my experience. I have a family member who's a CEO of a very large utility company. And he says, Mike, we have all built climate change into our resiliency models. You look at the BP and the Shell scenarios out to 2030, they're all building climate change and global warming into their business models. So that's not to defend big oil. I'm just saying it's, you know, they realize what's going on. Okay, so that's a little bit about media and the bias. I'd be happy to send out, you know, links on some of the, you know, when I talk about Dan Kahan and his cognition project. It's really interesting work. Okay, let's look at carbon. And so let's look at carbon and temperature and see what the record tells us. And as I approach this, we start working back to your question here, which I'll try and summarize, right? So this is an infographic that I've tried to come up with just to summarize the carbon cycle. There's no pop quiz or test at the end of this evening, so don't worry about these numbers, other than to illustrate one thing, a couple of things, but one thing in particular. Anything in red here are human additions to the carbon cycle. This is the short-term carbon cycle. So this isn't long-term carbon going into limestone rock or anything like that. This is short-term carbon cycling. So anything in red is human additions, and the 9.5 G, that G stands for gigatons, billions of tons of carbon, right? So we are putting out, on average, about 9.5 billion tons of carbon every year through from the emission of fossil fuels. That's human activity. And the 1.6 billion tons, the 1.6 gigatons, is carbon that is being added to the atmosphere from deforestation. That's often overlooked, but it's an incredibly important source of carbon. When you cut down trees, that carbon then gets returned to the atmosphere. So deforestation, tropical deforestation in particular, is an important part of the global carbon cycle. So humans, either through deforestation, what we do in terms of breathing and fossil fuel emissions, are adding about 11.5 billion tons of carbon to the atmosphere each year. Okay, that's the take-home message. All of the blue things here are natural cycling through oceanic cycling, soil respiration, vegetation, and so on. And when you add all these numbers up, this 2 billion tons over here, that's how much the atmosphere, the soil, the ocean takes out over and above the natural cycling. So we are adding in 11.5 billion tons of carbon to the atmosphere through human activities, and the Earth atmosphere system takes out 2 billion tons. So that gets back to the 9.5. That's the big bottom line, is that we are adding about 9.5 billion tons to the atmosphere every year. And we've been doing that now for decades, if that makes sense. The next slide here, now you're going to look at the scale here and go, whoa, wait a minute, what's going on here, right? So this slide shows the emissions of carbon dioxide, CO2. So this is not carbon, this is carbon dioxide, right? So when you look at the scale here, you'll see 20, 30, 40 gigatons of CO2 per year, or 40 billion tons, right? So that doesn't seem like it's the right scale. And I always like to show this because you'll see that in the media. They'll either be showing carbon or carbon dioxide. So I'll go back just 1 second. If you've got 10 billion tons of carbon, right, as C, that is the same as saying about 37 billion tons of carbon dioxide, because the atomic mass of CO2 is heavier than carbon, right? Carbon is just the element carbon. CO2 is carbon plus 2 oxygen 16s. So just be aware of that. I'm sure you are. And but if you're not, I think that's a fairly important thing to point out. So this 9.5 billion tons of carbon that we're adding to the atmosphere by fossil fuels, if you just multiply that by 3.67, which is the multiplication factor, that's where you get to about 35 billion tons of CO2. So you should be comfortable just switching between carbon and carbon dioxide. It's just a factor of 3.67. This is really interesting to me. These numbers have not been finalized yet. What COVID has potentially done to the carbon cycle in 2020. I haven't seen the final. There's a really good website called Carbon Brief, carbonbrief.org. There's also, this comes from a website called the Carbon Project. That's another really great one. So the estimates are that COVID will have reduced CO2 emissions by about 7%. I don't know if necessarily I'm advocating for a pandemic from an atmospheric perspective, but we've seen that around the world, how the atmosphere sort of cleaned itself up. And then just as a frame of reference, when we think about carbon and adding carbon to the atmosphere, these are the big emitters, okay? This is at the end of 2018, so I need to update this for 19 and for COVID, but I'm waiting on the COVID numbers to do that. The size of the bubbles here are all scaled to one another. So when you look at the top 10 emitters of CO2, the top 10 account for something like 2/3 of all the CO2, right? And so China is the #1 emitter on an absolute basis, not per capita, but on an absolute basis. China is #1, the USA is #2. You can see India is #3. So when we think about climate policy and what's probably going to happen in Glasgow in a couple of weeks, 2-3 weeks like that, the COP26, the big climate conference, without having the US, India, and China at the table, we won't remotely meet our emission reduction targets, not even closely. So that's currently the top 10 in terms of CO2 emitters. Okay, so what's CO2 done? So I'll walk you through the short, medium, and longer term, and then I'm just going to bleed that over into what's temperature done, and then we can look at some of the evidence on the ground, right? So all of this is available online. If you go to NOAA, the National Oceanic and Atmospheric Administration, this shows the CO2 record from Mauna Loa. So this is kind of the gold standard. Al Gore opens An Inconvenient Truth with the CO2 record, the so-called Keeling curve. So the CO2 record from Mauna Loa goes back to 1958, and there has been an unrelenting increase in CO2. This shows the pre-industrial revolution from something like about 280 parts per million. We're now at 415 is the official parts per million for 2020. So again, when you convert that into a percentage, that's 0.0415% of the atmosphere, right? So there's been about a 35–40% increase in the last century, and about almost a 50% increase since the Industrial Revolution. You'll see here on the slide, you'll notice these little orange squiggles up and down. That's just showing the seasonal signal, right? So carbon dioxide goes up in winter when vegetation dies back, and in summer carbon dioxide goes down a little bit when the vegetation is in full bloom and sequestering carbon out of the atmosphere. So that's always the starting point for me, the ramp up in carbon dioxide. And it's actually, incidentally, the place that I start when I start thinking about your question, right? This is not rocket science. This is straightforward environmental science. We can measure this, we can observe it, it's quantifiable. Okay, it is also important to look at a short-term carbon record like we have over the last 70 years. How does this play out over the longer record? So on this slide here, these gold diamonds, this is the so-called hockey stick, right? That has been quite controversial. The gold diamonds are the carbon dioxide record from Mauna Loa. Everything else on the screen, whether it's the red triangles or the blue circles, the X's, these are all carbon dioxide taken out of Greenland ice cores. Okay, so you're able to, the snow packs up and you're able to suck out that atmosphere and date it and measure the amount of carbon dioxide in those ice cores. So when you go back 1,000 years, I think there's such an overwhelming consensus now that at 415 parts per million, we are in a very different position than we've been over the last 1,000 years. And in fact, if you take that back, we can almost go back 1 million years now. About 4 years ago, they published this data going back 800,000 years. This shows CO2 taken from Antarctic ice cores. Various agencies have been drilling into the Antarctic. So this goes back 800,000 on the left-hand side of this diagram through to the present day on the right. And you can see how carbon dioxide is, we call it being phase locked in this band between about 180 to about 280 parts per million, right? So we go through you can see the glacial cycles here, right? When carbon dioxide goes down low into the sort of 180 to 200 parts per million, those are major glacial cycles, and then it gets warmer to where we currently are and so on. There's a very good overlay of temperature on this diagram as well. The blue star is 415 parts per million. So again, I don't think there's any doubt that we are in uncharted territory when it comes to CO2, if that makes sense to everybody. So what's temperature done, right? So this is the big controversial one, where we try and look at millions of data records around the planet, correct for things like urban heat islands. So each one of these lines represents global temperature for a year relative to the 20th century. So the horizontal line, that is the 0 line, that is looking at all temperatures summarized to one mean. So we've got that at a 0% line. And then any year that lies above that is a positive anomaly. Anything below that is a negative anomaly. Obviously, as we go a little bit further back, right, towards the 1800s to 1910s, 20s, and so on, we don't have nearly as many records. We don't have satellite records to corroborate this. So the record gets better as we go to the right, right? So this is the so-called global warming signal, okay, where we go from temperatures that are about 0.4 degrees below the 20th century average to where we currently are, something at about 0.8 to 1 degree Celsius above the 20th century average. So the latest average, that's the 2020, we were 1.02 degrees Celsius above the long-term average, right? So anyone who says global temperature is not going up, it's not warming, that's just simply not true, right? The data is what it is. Any questions on that? Does that make sense to everybody? Here's another fun way to look at it. This one's done by a Finnish meteorologist who gave me permission to use this data to publish the way in which you may have seen this. It's a really nice animation. I won't do the animation, that's available on YouTube. But what he did is he went back and, would you just hit the screen again, Frank? Or just click the mouse? Thank you very much. So he went back and took the global anomalies for every country, and they're in 4 quadrants. So you go from A to Z, from A to Z, from A to Z. So that's all those countries wrapped around here. And the rings, this 0 line that you see at the center over here, right? Is there a pointer? Yeah, so that 0 line is the 20th century average, and then it's each country shows above or below that. So that's 1900, and that's 2016. It's pretty hard to argue against this, right? I just don't see this as being a global climate conspiracy somehow, but that may just be me. When, just like carbon dioxide, again, context is important. So this diagram here shows the 20th century temperature record. So all the red diamonds are the 20th century, and then the green and the mustard curves, and we could probably overlay something like 12 to 15 curves from various studies. This shows temperature reconstructions from ice cores, right? And there's wiggles and squiggles depending on where you sample the ice core, but there is now a very strong consensus, right, that global temperatures in the last 100 or 120 years are about 1 degree to 1.5 degrees Celsius warmer than they have been over the last 1,000 years, right? And when you just look at the correlation between carbon dioxide and surface temperature since the carbon dioxide record started on Mauna Loa. So this is carbon dioxide in the mustard curve, this is temperature in the red curve. Those two have a very, very high correlation. I always tell my students, be wary of correlations and whether it's actually causation, and I like to use this one. This is a funny website. It has all sorts of really cool correlations. There's a correlation between crude oil and chicken consumed in the United States. It's actually even stronger than temperature and carbon dioxide. But this is a fun website called Spurious Correlation, so you can always take that with your students. There's a nice one between asthma rates in California and the number of strikeouts by right-handed pitchers at Coors Field. That's got a correlation coefficient of 0.95. But anyway, so that's just an important aside. Things get very controversial, I think, here when you start talking about, well, what's the next 80 years, right? Now we're moving into this fuzzy realm of prediction, computer models, and that's where people start getting a bit more skeptical. Okay, well, hang on a second. Now you're just going to believe a computer that it's going to tell us what the climate will be in 2100 when we don't really know what the weather's going to be like next week, which is a very skewed way of portraying climate. But what I've done here is I've plotted blue is the global temperature going back from 1880 to 1979, and then red, I've just extended that to 2019. I need to add the 2020 data. So that's the temperature record. And then this sort of pie triangle that goes out is the range in global warming predictions going through to 2100 by these climate models. And the big bubble is where the consensus is. Most of these climate models sort of can begin to converge here at about another 2 degrees Celsius warming, right? Is it going to be 2.5, 3, 1.5, 1? I mean, we don't know is the honest answer. But the way in which, these climate models are extremely sophisticated, but we wouldn't expect them to be perfect, right? We won't know what global warming will be in 2100 until January the 1st, 2100. I don't think I'll be here. So this gets much more complicated, right? But I think that's the consensus. And you'll hear that in the media now a lot in the next couple of weeks as we approach COP26 in Glasgow. a lot of attention was focused on how do we keep the global temperatures below 2 degrees Celsius, which is the consensus. And now climate scientists are saying that's probably not good enough. We need to be below 1.5 degrees Celsius to try and avoid the most catastrophic outcomes of global warming. And then finally, let me just talk a little bit about impacts, and then I'll wrap it up. And let me not answer that spam call. So what are some of the observations that we see on the ground that are consistent with global warming, right? And again, I always caution people, if there's a particular storm comes through, so an Imelda comes through, or a Harvey comes through, or Katrina comes through, just from an atmospheric perspective, we often see that on the media, right? Well, here's a big hurricane that's hitting the US. This must be because of global warming. And I always caution people about that. I think everybody in the room and on Zoom will appreciate that, right? That we're not looking necessarily at one event, but we're looking for trends over time. So this is one trend that I think is pretty solid and unmistakable, what's going on around the world in terms of wildfire seasons, right? We're seeing that the wildfire seasons are getting longer. So it used to be 5 months, they're now 7 months, and the fires themselves are getting bigger, right? So this just shows the average annual acres burned per wildfire in the US, right? Again, we can measure this. This is quantifiable. This isn't a Democrat or a Republican thing. It's a fire. And this is consistent with, I think, what we're seeing as the world begins to get warmer and dry out. Of course, a picture is worth 1,000 words, and we often see this. This is some of the most widely used lines of evidence in terms of global warming. Climate change is glacial retreat. Glaciers are melting. So these are various scenes from around the world. I particularly like the one at the bottom. That's from Argentina, and you can see here on the right is the snout of the glacier in 1931. And in 2010, that had receded all back around the corner. And we're seeing evidence of this around the world. I saw this. I don't know what's going on. Another click. Let's keep it going. Oh, that's the Athabasca Glacier. That's a very well documented one. The front is where the glacier was in 1925. The glacier that is now in 2012, this photograph was taken, right? So glaciers are retreating. This has enormous implications, not just for, oh, I can't go and look at a pretty glacier, but many people in the world rely on glacial melt for their water. So in the Himalayas, for example, this is becoming pretty acute. I saw this firsthand a couple of years ago when I went to Iceland. I don't know if any of you have been to Iceland. I highly recommend it. It's critically expensive as a place to go and visit, but once you're there, it's great. And this is one of the places that most people go in Iceland, around the bottom of the ring road. The blue blob there is where this lake is. It's a well-visited lake. This is called Jökulsárlón, and it's a glacial lake. On the left-hand side of that photograph, you can just see a bridge. That's right where the glacier snout was as it emptied into the Atlantic. And that glacier has now receded. This lake wasn't there in 1945. The glacier was right on the coastline, right? So on the left-hand side is a diagram of that location, and the green line is 1945. That's where the glacier was, right at that bridge. The red line is where it is in 2016. That glacial lake has now quadrupled in size since 1970, right? It's just getting warmer and warmer, and that glacier is receding. So we see that around the world. That's very common, right? We know that the extent of Greenland's ice melt is changing. So this is an extraordinarily important ice cap for a number of reasons, but this shows the total melt area in how many million square kilometers, and you can see that that's grown over time. As you would expect, there's quite a bit of variability in there, but we look for trends over time, right? So in the last 30 or so years, 40 years, the area of the Greenland ice melt has gone up from on average about 20 or so million square kilometers to about 30 million square kilometers. Seems to be wedged in that region. One of the reasons why this is so important is that if this was to dewater, if that extent keeps going and more of Greenland begins to melt, then this has real potential for shutting down the North Atlantic conveyor belt. And that is how ocean water is circulated around the planet. So this diagram shows a very generalized, broad picture of surface warm water and subsurface cold water. And we know that the North Atlantic drift in the Gulf Stream moderates climates in Western Europe dramatically. And if Greenland was to begin to seriously melt, you would potentially shut that conveyor off, right? And so the climate of Western Europe will change pretty dramatically. Other things, of course, sea level rise, right? Some of you may remember the sort of photographs in the 1980s in Time magazine of the Statue of Liberty with, just the flame poking out through the ocean as sea levels begin to rise. So yeah, some of those were exaggerated for sure, but this shows the sea level change up through 2019. Again, I haven't updated this until 2020. So the red lines here are historical observations of sea level rise, and the blue lines are satellite images or satellite telemetry measurements, which are now very, very accurate and precise. And so sea level is rising, over the last, we'll just look at the little box there, right? In the last 5 years, sea level's been going up by about 6 millimeters per year. That doesn't seem tremendously high, but 6 millimeters per year, 10 years, you've gone up, 60 millimeters, that's 6 centimeters. Again, that doesn't seem very much. We're not going to get beachfront property here in DFW anytime soon. But if we're going to look at about a foot of sea level rise in the next 50 years, and you live on Vanuatu or you're, living in the wetlands of Louisiana, there's going to be significant concern for sure. So sea level is still a major concern. And then, of course, there's the opening up of the Arctic, which is great if you're in shipping and you want to move goods across through the Arctic. But that also has profound implications, I think, for habitats, especially habitats for polar bears. This shows the extent of the Arctic ice, right? So from 1979 to 1983, on average, the aerial extent of the Arctic ice was about 7 million square kilometers. We're now, in the last 5 years, under 4.5 million square kilometers. Just more lines of evidence that are consistent with a change in the Arctic. And this is a view looking down here on top of the Arctic. So the white is 1982 to 1982 September, and the blue is September 2019, right? The Arctic is melting. That ice is beginning to melt, opening up the North Passage, and of course then opening up the possibility to oil exploration, which is a whole nother environmental issue. And then finally, this is one that I think is often overlooked but shouldn't be, and that is what is potentially happening with the permafrost, right? So permanently frozen ground that has locked huge, vast quantities of methane gas in that permafrost. We currently have an estimate of something like 23 million square kilometers of permafrost under Siberia, Greenland, and the Canadian Arctic. And that permafrost holds, estimates put it at about twice the amount of carbon that the atmosphere does hold. And the real challenge here, I think the great concern is that as that permafrost begins to melt, as the world warms, it also will release methane. And methane has a much higher GWP, global warming potential, than carbon does. It's a much more powerful greenhouse gas. And so anything that we might do in terms of carbon could potentially be swamped by the melting of the Siberian permafrost. So the question is, what do we do, right? In all of this doom and gloom, it looks like we're rolling the dice with this planet. Do we, and we're going to see that unfold in Glasgow over the next couple of weeks, or in a couple of weeks' time. What do we do? Do we just, use the sort of wait and see principle and go, well, let's just wait and see until we're absolutely certain that global warming is going on? Some people like that approach. Others say, let's get started. We're 2 decades too late, right? We need to do things now and put policies in place now. With carbon, it's controversial. Should it be a cap and trade? Should it be a carbon tax? The carbon market has been, I think, largely unsuccessful. How do we put a price on carbon? All of these things are still being debated, and yet here we go, year after year after year. So this is what I do. This is my little take this, and maybe this will help you. Maybe it won't. I don't know. So I'm spending most of my 401 at Starbucks, as I did this evening again. And so this is my simple approach when someone says, do you believe in this global warming thing, right? So I do one of 3 things. I say that we've known for centuries that certain gases in the atmosphere, like carbon dioxide, prevent Earth's heat from escaping. Okay? Our Earth would be a frozen ball without that, right? We also know that emissions from human activities, such as vehicles, which we can measure directly, are thickening those layers of gases like carbon dioxide, okay? And that is preventing heat from escaping from our planet. And finally, that observations of temperatures going up, sea level rise, and melting glaciers look like they're confirming this added warming. And I just leave it there, right? So we know that the greenhouse effect is real. We know that humans are adding greenhouse gases to the atmosphere, and we're seeing a fairly consistent response in terms of sea level rise, melting glaciers, and temperatures that tend to look like they corroborate that. And then see what people think. I've personally just met so many people, whether it's some in the room now in Costa Rica, farmers in South Africa. The earth is changing, right? Things are drying out. You look at what's happening in California at the moment with drought cycles. It's a pretty gloomy picture, but that's my quick take on climate change and global warming. So questions, thoughts, comments, counter arguments. Let's hear them. Yeah.
Did you say China is going to be at Glasgow or not?
Yeah, I think they are. That's the last I saw, that China will be there. The timing is really unfortunate, right? In terms of what's going on with supply chain and the energy crisis around the world, and the price of energy, the price of natural gas, the price of oil, things are really ramping up, and I don't know what that's going to mean in terms of the so-called energy transition to renewables. It's just, I mean, in 2009, President Obama went to Denmark with basically his hands tied behind his back, right? In terms of the split in the US House of Representatives and the Senate. They've just come out of the global financial crisis, and it's pretty hard to argue a carbon capture cap or a carbon tax in that. Not much happened. Certainly President Trump wasn't keen to go that route, and I know President Biden has made lots of noise in terms of reducing carbon emissions. China's an interesting one. So President Xi said that China will be net zero by 2060. So that big, bubble should at least go down to zero by 2060. But that's going to be an extraordinary lift.
I have a question.
Yeah.
Do you have any observations to share regarding the El Nino phenomenon?
Yeah. So El Nino, just in terms of how it plays out of temperature cycles, or is there a bit more context there? Just a general question about.
General question.
So a general question, yeah. So it's an interesting one because in all of this, and I really try and stress this in my classes as well. A big theme, of course, is natural cyclicity versus anthropogenic cyclicity or anthropogenic signal. So we know that the El Nino and La Nina phenomenon is a sort of 2 to 7 year cycle of the warming of the sea surface temperatures of the west coast of South America, and that changes global weather patterns, right? Those links are not just sort of circumspect. We're starting to see real, strong correlations between the Atlantic hurricane seasons and what's going on in the Eastern Pacific and the change in the entire circulation across the Eastern Pacific, or drought cycles in Southern Africa, for example. So if the question is just generally, does El Nino impact global circulations? Absolutely. The more difficult one is how do we tease out the impacts of something like El Nino or La Nina with, the global warming signal, or at least anthropogenic forcing of climates. I don't know if that answered it or not, but.
Well, if you kind of look at it like this, like just people can argue with you, well, we've always had these cyclical changes,
Yep.
We've had ice ages, we've come back, blah, 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 and you say, but when did we start driving cars? When did industry come out? And then you can show them the data, look at the, exponential increase in carbon from that. So it wasn't just that we had an uptick, there was human contribution to that. So can you do the same thing with El Nino and that cycle?
Yeah, you can. No, you can, absolutely. And so I hear that a lot, right? And I'm sure I'll hear that in a few weeks' time around the Thanksgiving table when I'm with my extended family. And they're absolutely right? So if any climate scientist says, well, climate change is driven by humans, and there hasn't been, of course there's been climate change without humans, right? We know that we've gone through 8 or 9 glacial cycles. Say again? Yeah, exactly, right? We know that most of the world's coal was formed during the Carboniferous period when CO2 levels were much higher than they currently are. But that's climate change over hundreds of thousands and millions of years when you've got, maybe a few million people living on the planet. We're talking about climate change over 100 years when we've got 8 billion people on the planet who might need food and water and things like that. And oh, by the way, another 2.5 billion that are coming along by 2050. So for me, of course, there's natural cyclicity, and we've had climate change that has had nothing to do with human beings. But I think it's just irrefutable that humans are now the dominant vector, at least in the last century and a half. And I think it would probably behoove us to do something about it sooner rather than later. But yeah, I mean, it's a very important question, right? And again, you can go round and round and round in trying to tease out the nuances of an El Nino cycle versus a global climate cycle, or an individual hurricane versus, I've heard things like, well, it's been an unusually cold, cold period over the South Pole and the stratospheric. I mean, yeah, you've got all of this variability. So now we start looking out at longer term trends.
Oh, the Zoom group is got some questions.
Yeah, but they're just hiding behind Zoom. They're not.
Is what's happening in our oceans more influential for climate change than what is happening on?
Okay, wow, that's a great question. So I'm not an oceanographer, but my guess is probably yes, right? Because the ocean stores such vast amounts of heat. And of course, when you start adding carbon through the system and you're increasing carbon, you're acidifying the ocean. So are they referring to things like coral reef bleaching, or just more of a kind of energy storage?
I can't.
I would say it's probably a general question.
Yeah, no, I think
If I were doing it myself, I could do it, but I can't help you.
Okay.
yeah, I think that's
Got a mute newt. Okay.
a moot newt. Yeah, no, I think that's a critical question. One of the most difficult things in the climate models was to couple the oceans with the surface. A lot of things was with all of the climate models early on, at least in the 80s and the 90s, were surface terrestrial based models, because we just didn't have a handle on what was going on in the oceans, especially deep oceanic circulation. So they got a much better understanding of that now. But yeah, the oceans, they do hold the key. They're absolutely critical in terms of long-term storage of heat.
I have
A question up front here?
What do we need to do to fix it?
That's right. All of this
We need
hypothetical.
to fix it.
Yeah.
What do we do?
Well, so that's a really good question. What do we need to do to fix it? We need to move. So this is just my 2 cents. We need to move the energy transition along much more quickly than we are. I mean, I think that's the bottom line, because that's where the majority of the carbon is coming from, right? The combustion of fossil fuels. So we need to move this transition to renewables, I think, far more rapidly than we're doing. I mean, it's happening. We're starting to see places like China run away from us in terms of solar panels and and wind farms and things like that. But that's a challenge in and of itself, because how do we pay for that, right? The climate scientists is a very influential group of climate scientists that say the only way forward is nuclear. That's our only solution. Yeah, exactly, right? Wow. So how do you, okay, well, they're right from, a bang for your buck, because nothing comes close to nuclear power. You cannot put up enough wind turbines or solar panels over any amount of space to produce a gigawatt of power than you can off one little silo. Now, when nuclear goes wrong, it's tricky, right? It does go wrong. But more importantly, the financing is very tough, right? The economics of nuclear, or at least of traditional nuclear, of pressurized water reactors, I mean, it takes 12 years to build a nuclear power plant, and it's something like $10 billion. That's a lot of construction loans. So there's a reason why so few nuclear plants are being built. And that 40 years time, most of them will be offline, at least in the United States. So, to get back, so the point is, yeah, there's lots of little things that we can do individually, but at the big picture scale, we've got to transition to a much cleaner future, whether that's a hydrogen economy or just begin to ramp up renewables faster than we can. And of course, the flip side of that is someone will say, okay, well, then how do we provide electricity to so many people? Again, there's 1 billion people that don't have electricity at night. And then those 2 billion come along. How are we going to do that? And there's a strong argument that natural gas is the only solution until such time as we can truly build out a grid that can handle intermittent resources. And as soon as you raise natural gas, people go, I don't want that. I don't want to hear about natural gas and fracking. So it becomes very complicated. It does. Yeah. Zoom question.
How much relief will electric vehicles provide? What are the downsides?
Yeah, another good question. In the short term, the relief, unfortunately, is very, very small. I think it's more of a feel-good. This is maybe controversial, but I think it's more of a feel-good factor in the short term until we can get large-scale electrification going on. Of course, an electric vehicle, is much cleaner than a gas-powered vehicle. But the flip side of that is, well, and you got to make the battery somewhere, and all of the rare earth elements that go into that, and so it's a very complicated picture, right? Because some people like to look at it just as, well, there's an emissions here and this doesn't have an emission, so this is much better than this. But when you lay it all out and you try and levelize the costs and levelize the true life cycle greenhouse gas emissions, it's a much murkier picture. But yeah, I think in the short term electric vehicles are not the answer. In the long term, perhaps they are. I like cars that make a noise. So I can't.
I have a question.
Yeah.
What about agriculture, the animal contribution?
Yep.
Because of the methane.
Yeah, cows are the real hogs, right? When it comes to that.
That's what they tell us.
Yep, they are. Yeah. So methane for agriculture. I mean, just from an energy perspective, it makes no sense, right, to grow crops to feed to cows. I mean, we know that. And, I am not a vegan or a vegetarian, and had a fantastic steak in South Africa 2 nights ago. I mean, so I'm a hypocrite when it comes to that. But cows consume something like 85% of all the world's biomass and produce 8% of the protein, 8% of the food to the planet. It makes no sense to waste all this land for cows, but we do, right? And then as the world, especially the developing world and Asia, South and East Asia, they begin to develop Western eating habits, and then the knock-on effect is, well, where are we going to get that land from? Well, we're just going to go into the Amazon, right?
But it's like a big secret. A lot of people don't even think about that. It's something that just people don't talk about because God forbid they would have to give up.
Yeah.
Like, I eat hamburgers too, but I mean,
Yeah.
it's just not brought up a whole lot.
Yeah. And then you go to, well, if we should all become vegetarians and vegan, well, you still need lots of space to grow all that food. There's no easy answers here. When
At least 8 times less.
Yeah. It just doesn't taste as good.
Okay, we have a persistent questioner here.
Uh-oh.
And this questioner started out asking about a fossil fuel treaty. But I think the questioner has come to the bottom line here. What is your opinion on the helpfulness of a carbon tax?
So I think a carbon tax is the way to go, but there is enormous complexity in what that number should be, in who sets that carbon tax number, right? How do we put a price on carbon? It's been tried. The European carbon market has been more successful in the US, but still, no one likes taxes. And how do we tax carbon? I just don't have the answer to that, to be really honest. How helpful will it be? Some people say that we need to go to a cap and trade program, right? Which seems to have worked quite well for Mercury when you trade this all on the open market. And if your industry is polluting less, then you can sell your carbon credits. But I just think the carbon market is just, it's kind of like Bitcoin. I'm just not quite sure how it works and how successful it's likely to be in the long run. So the people I talk to are, proponents of carbon tax rather than cap and trade. But I just, I wouldn't be honest saying that I have any definitive insight into how helpful it would be. It's a great question. I don't know how they're going to implement a carbon tax. I don't know how they're going to do it.
Another interesting question, which I think the bottom, the core of this question, and forgive me, questioner, if I'm misinterpreting, is where should we spend our energy? What do we try to save? I think that's what the person is trying to ask. So should we stop trying to convert desert areas? I presume that means to farmland or back to prairies, and conserve resources that we have to maintain these at-risk areas, which I think may mean Greenland and some of these others. That's my interpretation.
Yeah, I'm not quite sure I'm getting the crux of of that question? Are they asking we should when they say not going to desert areas? Are they talking about solar expansion into desert areas? Or
I don't think so.
okay, yeah,
We're trying to make them.
Basically, excuse me, pardon me. Basically, I mean converting the desert areas for population increase instead of using up all our resources to try to turn a desert area into a green neighborhood. Why not use that for the areas that need those resources that were already the green type areas, the ones with the vegetation, instead of converting a desert?
yeah. So I mean, obviously, I agree, right? If you're trying to, I got a friend who takes me to Las Vegas once a year, and you land there. I don't know if anyone's been to Vegas recently, and it's the most incredible sight, right? You've got golf courses everywhere and these green patches, and yet the Colorado River is now almost non-functional in terms of its water levels within Lake Mead and so on, right? So the conversion of desert areas into greener areas is just not sustainable in the long run, and that's just simply from a water perspective. I mean, that doesn't, you don't need to be an engineer or a scientist to figure that one out. The problem on the other side of that, I think, if I understand it, the question is, using the green areas that we have, currently, and using them wisely. That makes perfect sense. The problem is, just think about food for a second. I think the consensus is that we're probably going to have to increase our crop yields by something like 50% by 2050. That varies tremendously whether you look at what literature you look at, but I think there's a consensus around 50%. We have to increase our food by 50% in the next 30 years to be able to feed that 2.5 billion that's coming along. Oh, and the current billion that go to bed, hungry at. How do we do that without going into the tropical forest, right? Because there's not enough cropland just sitting there waiting, saying, okay, come on down and plow me. This is perfectly good virgin soil just waiting to be put under the, we know that we already have such marginal soils under agriculture. So how are we going to do that? I mean, I think that's one of the most pressing issues that we face. Estimates are that we're going to have to put another 2 Indias under cropland to increase those yields by 50%, unless there's some dramatic new food revolution that's coming along the way. So I don't know if that directly talks to the question in terms of, utilizing our resources or not, but it's a good one.
Do you know of an example of a country or countries that are doing a good job with reducing their impact? I just heard NPR talk about Denmark.
Yeah.
And gee, if we were only 5 million people within the size of, I don't know, Tarrant and Parker counties, we could do a great job.
So that's kind of tongue in cheek, but it's critical, the question of scale. I'll use a country that 2 in the room are familiar with because they've been there with me. So Costa Rica, same population, about 5 million people, right? And Costa Rica has done a tremendous job. One, from a reforestation perspective. So, in the late 1990s, Costa Rica was down to about 20% coverage of its tropical forests. It's now almost 55%, right? So they've totally turned the corner in that. They want to become the truly first carbon neutral country. Now they're blessed because their electricity comes from hydropower, from wind, from solar and geothermal. They use less than 5% of their energy comes from fossil fuels. So that's a huge help, right? So right there along, again, they've got a population the size of the Metroplex, so it's much more manageable. The reason they're not going to get there anytime soon is their transportation, because they still use sort of older vehicles, diesel and oil. But that's one country that has done a very good job. And Denmark as well, that would join us, Sweden's. It's how you look at it. But now you scale up to 330 million at our consumptive levels is a whole different challenge, right? And then you go, a couple of years ago, I was in New Delhi, and you look at a country like India, right? So India has to get electricity to about 500 million people. That's all. 500 million people don't have access to electricity, right? And electricity is the fundamental driver of development. We know that. You can look at GDP versus electricity consumption, and the US and Japan and Denmark and Sweden, they're all up here, and the developing countries are all down here. So what's going to happen when they start moving up that? They get richer, they consume more, they get richer, they consume more. that becomes more problematic. So I'll throw out Costa Rica as the poster child.
I think it's time, there are still more questions coming, but I think it's time to give Dr. Slattery a break and thank him for providing us this information. And I hope those of you who didn't get your questions asked, you just blame me. That's okay, I can take it. But thank you so much.
Yeah, you bet. You're welcome.
We're grateful to have you here.
Good. Yeah, no, I'm happy to hang around. And if people want to email me, I mean, I don't profess to be not even remotely the world's expert on climates. There's some really, really good climate scientists doing some stellar work. It's not a conspiracy. I can assure you that. They're trying to unlock this very complicated thing.
Let's give him a.
Good. There you go, Frank. Thanks for doing the
Yeah.
navigating all of that.
This is our second hybrid meeting, and I want to thank Frank and
Yeah,
Sharon.
that was smooth.
Oh,
good. No, that was good.
Thank you very much.
Yeah, you bet.
Now I have to make some announcements,
No.
right?
I'm going to sit.
Oh, good. The first announcement is, and Frank, if you could deactivate the slideshow,
I could do that.
and then we'd like to get Gina Alexander on. And Gina, let me know, yell at us if you can't, unmute yourself and tell us if you can't share. I'll have to figure out how to let you share.
Well, I'm actually just going to speak if that's okay.
Sure.
Can everybody hear me?
Yes.
So 2 months ago, we had a meeting in August with David Buggs, who was the Chief Diversity and Inclusion Officer for Texas Parks and Wildlife. And he shared with us quite a bit about really a movement that's happening within lots of chapters for master naturalist groups. And when I had a chance to visit with the board, I think it was 2 weeks ago. Is that right?
Yes.
Everybody was there was so much support for us really getting at some of the recommendations that David Buggs shared. And if you all remember, I'll just jog your memory. He was saying, how do we get started with this work? How do we get started in promoting our chapter, getting to a place where we do have a more diverse membership? How can we be more inclusive of many different people from our community applying and being part of the Master Naturalist cohorts? And you might remember his bottom line was basically, we all need to learn how to be comfortable being uncomfortable until being uncomfortable becomes comfortable. That was one of my takeaways from his message. And, basically he was saying he had several strategies. He shared that there are several groups that already exist. Unfortunately, I looked up several of those groups and they're not in our area. So there's Black Outside, Outdoor Afro, Outdoor Latino. There's a lot of different organizations, but none of them have a chapter in our area. So he did say, though, we can start small. And so one of the recommendations he suggested, his term was an urban outreach advisory team. I thought that would be great and we can get to that point. But when I talked with the board, we were thinking maybe we start just with a committee. I'm not sure, since I'm one of the newer master naturalists, I'm not sure if that's a structure that you all are comfortable with, but I did have a couple of people on the board who expressed interest in being part of the committee. And I wanted to make this announcement just for anyone who, I'm not physically there, so those who are physically at the meeting and would like to be involved in a diversity, equity, and inclusion committee for our chapter, if you would maybe give your information to Sharon and she could share it with me, I guess that would be okay. But anyone who's on Zoom, if you could drop your email into the chat, I will follow up with you. But we just think that we get so many great recommendations from that meeting, and I felt like it was very inspirational in August. Just you know, being honest, being curious, being open to others, growing and reaching parts of our community that really aren't reached and don't have as much of an understanding of the natural world and preserving and conserving natural resources and how important that is. So so anyway, if anybody has anything else they want to add, I'd love to open that up, but I just wanted to share that we have a lot of interest, and I think it'd be great to have more community members, more members of the committee be involved. And I'm willing to support the work. I would love for someone with greater ideas than me to lead it, but I'm willing to lead it right now because we don't have anyone who stepped forward. So so yeah, I think that's the extent of my announcement. I'm sorry if that was too wordy.
Not at all, not at all. And I see that you're getting replies already.
Yes,
So
on
good.
Zoom, a lot of
Good.
replies. Thank you all so much.
As if I know you had to hear it, you hear it every time. As a retired teacher, you hear it from me. I think a lot about the future, and I think some of the data and those things called facts about our state and the demographics that have already changed and will continue to change. I guess my philosophy is that if it matters to me to preserve our state's natural heritage, I want it preserved 20 years from now and 30 and 40 and 50 years from now. And the more types of people we can include in this challenge, the better that is. Right. So thank you, Gina. Eventually, soon, there will be a small change in the homepage of the website down at the bottom. There, in that section where it says pay your dues, it will have, you'll be able to pay your 2022 dues. Now, right now, it doesn't say that. So don't try to pay 2021 again and get us all confused. Just wait until it says 2022, and then if you'll please pay your dues. People often ask, what's the deadline? Well, you know deadlines. So for now, I'll say January 30th. How does that count? How does that sound? And we'll probably remind you again, and then we extend, but still think about that. Dues are $20. They haven't changed for many years. To me, just the networking and the great presentations we have, like tonight's talk, are more than worth that $20. Yes, ma'am.
The trainees for 2021. Okay.
Oh yeah, okay, trainees. 2021 class, you are already paid for 2022. Woohoo! All right. Another thing that another piece of media or social media or email you'll get from Sharon through Frank through Mary Beth in the next couple of weeks is we're trying to decide whether to plan an in-person holiday party for December. Before COVID, there was always a get-together in person in place of a meeting in December. Right now, I'll say save the date, Monday, December 13th in the evening. And we're working on getting a venue where we can have social distancing. I could tease you that we might actually have real entertainment this year, as in people who are musicians that are members, which sounds pretty cool to me. But there are a couple of things we'll need to know, and I guess or maybe just one thing, how many of us are willing or feel comfortable attending something like that? And so I'm working with Tarrant County to see if we can get a good size space But then, and the question is, well, how many people do you think will be there? And I said, oh, between a dozen and 60, and in the past, it's been a potluck dinner. We're pretty likely not to have a potluck dinner again because of COVID issues. But, soft drinks, beverages, and perhaps my idea was the Swiss pastry shop, Black Forest cake. I mean, you haven't been to Fort Worth if you haven't had that. So if you see an email that says, please tell us whether you are willing or think you might be able to attend in person, please let us know, because we're going to have to make the reservations pretty soon. Any other announcements? Thanks, everybody. Thank you. Thanks again, Dr. Slattery. We'll really appreciate it. You just barely, he just made his connection by 2 minutes from South Africa. So we're very grateful you were here. Thank you in person. Thank you, Zoomers. Thank you, Roomers. And the meeting is adjourned. Over there.
Everybody saw it again.